It's Wednesday, June 24th. My name's Juan Brown. You're watching the Blanco Lirio channel. And breaking news, the preliminary report on the tragic loss of Pakistan International Airlines Flight 8303 is made public today. And everything we've been following about this accident so far appears to be spot on. However, this report adds some additional detail that indicate that this accident may very well be the worst case of human factors failings that I've seen in commercial aviation history. Let's go inside and take a close look. It's only 14 pages long.
Paragraph 16, wreckage, removal, and collection of vital evidence. Various aircraft components were identified and removed from the crash site. Few components were considered as vital for the analysis and were preserved. They were able to capture all the important data that they could from the aircraft, both the flight data recorder, the cockpit voice recorder, the EGPWIS, the ground proximity warning system, the flight controls data concentrator, the ADARU, the air data inertial reference unit. All this critical evidence was able to be found and the data recovered. Here's the left wing, which was located on the rooftop, the right wing section down in the alley, the left engine being removed from the rooftop, and the right engine down in the alley. Again, you can look at that right engine and see very little damage to the high bypass fan section, indicating little or no power to these engines by the time they hit the ground, corroborating the fact that both engines failed. The left main landing gear and the right main landing gear with them broken off of the airplane, that's further evidence that this aircraft, or that this landing gear was in the extended position. Remember the closed circuit TV footage we watched of the actual crash into these buildings indicated, or you could visually see, that the gear was in fact down. And it appears at this time that the gear came down normally. So they were able to secure the vital parts of this accident. That looks to be like an engine cowling piece, and I believe this is the trimmable portion of the horizontal stabilizer, the arm that moves to trim the horizontal stab. I believe that's the main spar mount, perhaps, mounting of the horizontal stab. And, of course, the enhanced GPWIS, that's just the cover to the box. Here's where investigators try to lay out all the bits and pieces and put this puzzle back together. On the left side of the photograph is the cockpit area, the front of the aircraft. Here's the left wing and the lower portion of the photograph, right wing and tail section back here. Heavy post-crash fire after crashing. So they were able to get all this critical data over to France, these folks here, the Bureau of Investigations and Analysis. These guys are experts at this work. Here's the flight data recorder. Here's the cockpit voice recorder. There was a lot of misinformation swirling around about the status of these components, but they got them and the data is fine, with one notable exception we'll explain here in a minute. This flight data recorder is going to hold the key to this entire investigation as this boils down to a human factors event. Here they're opening the flight data recorder, they're getting the circuit board out of it, and then they hook up the circuit board to the computer and read the data off of the circuit boards. Preliminary findings. The reported weather at the origin, en route, and take the flight. In other words, the weather was not a factor. This next sentence says a lot. This next sentence is the beginning of the end of the whole sequence of events, the whole chain, beginning to thread the chain of events through the Swiss cheese. On 22 May 2020, 8303 took off from Lahore. Departure from Lahore and cruising flight were uneventful. The crew did not follow standard callouts and did not observe CRM, that's crew resource management aspects during most parts of the flight. So there's something on the CVR recorder that investigators are flagging right away. What was the conversation going on? What was the conversation going on in that cockpit? Were there some major distractions going on in that cockpit? How was this crew working together as a team, like you're supposed to do with proper CRM, crew resource management? Paragraph C, Area Control Karachi East, that's the en route air traffic controller, cleared PK 8303 for the Nawabshah 2A arrival. Not sure on that pronunciation. The Nawabshah 2A arrival is a standard terminal arrival procedure into Karachi, and advised to expect the ILS, the Instrument Approach Landing System, for runway 25 left. Even though pilots are flying visual approaches, they are still cleared an instrument approach, and pilots typically use that ILS approach as a backup to their visual approach to A, make sure they're landing on the correct runway, and B, make sure they're descending at the correct descent rate for the runway. The flight was later cleared at pilot's discretion to report directly to Mockley, we'll show you that in a second here, and descend to 10,000 feet, and later recleared to 5,000 feet. The aircraft changed over to Karachi approach. This is the approach control, so you're going from en route controller to approach controller, and was cleared to descend down further to 3,000 feet by the time it reaches Mockley. So let's take a look at this. Here's the arrival. The Nawabshah 2A starts here over the Nawabshah VOR. 2A takes this branch here to this waypoint, and then aims you straight on into Mockley, which is about 15 DME or so off the end of the runway. And notice there's a little holding pattern there at Mockley. Also, here's your transition flight level of 500 or 050, 5,000 feet, and a transition altitude of 3,000 feet. Again, in other parts of the world, your transition altitude isn't always flight level 180. It varies around the world. That's the altitudes at which you change over from the QNH, or the home local airport altimeter setting, to a standard altimeter setting of 2992 or internationally 1013 hectopascals. Note on this arrival, there are no minimum altitudes that I can see on this ICAO instrument approach plate. Here's the ILS 25 left instrument approach plate, dated 23 April of 20. So this should be a current plate. Again, I'll show you the link to these. Here's Mockley, the 15 DME fix prior to final, coming into Karachi. Note the holding pattern. Let's look at the profile view. So the air traffic control has cleared the flight direct to Mockley and has cleared him all the way down to 3,000 feet with the intention of crossing Mockley at 3,000 feet. Now, if in the event that you can't get down or don't get down or need to do a procedure turn, you can cross Mockley up at 8,000 feet or even higher and do a left-hand 360 and descend in this holding pattern, crossing 20 DME at 5,000 feet and crossing Mockley at 3,000 feet. But this crew elected to just come bombing straight on in. Crossing Mockley at 3,000 feet should set you up well to intercept the glide slope from below, much easier than intercepting the glide slope from above, like this crew was attempting to do. We'll look at this profile here in a second. Paragraph D, the aircraft ended up higher than the required descent profile. Yeah, way higher. At Mockley, the aircraft was at 9,780 feet. If you're coming straight in to Karachi, you need to be at Mockley at 3,000 feet. So a fully 6,000 feet or more higher than they were supposed to be at Mockley. At 245 knots indicated airspeed. They need to be down to closer to 180 knots indicated airspeed by this point. In order to manage the descent and lose the additional height, open descent, this is an Airbus term, this is the equivalent to flight level change in a Boeing product. Mode was selected via the flight control unit, what I call the mode control panel, but I'll show you this in a second. Both autopilots were disengaged and the speed brakes were extended. So whoever's flying the aircraft is just disengaging the autopilot, open descending, and trying to jam the nose down to intercept the glide slope. Let's take a closer look at what this open descent means. This is Mike Abignale's YouTube page, and he's talking about Airbuses. This is the Airbus, what I call the mode control panel, flight control unit, Boeing, Airbus. I'm going to be flipping my terminology back and forth between the two aircraft, as it's been a while since I've been in an Airbus aircraft. Up here is how you control the autopilot and or the flight directors for the Airbus. Here's your speed selector, here's your heading selector, and here's your altitude and selector. This button here is where you hit open descent or managed descent. In the Airbus, if you push that switch forward, that's called a managed descent. In a managed descent, if you're on speed and on profile, the autopilot will fly the profile view in the flight control computer, the flight plan computer, and will capture all the different altitude restrictions on the way down. That's in a managed descent, assuming that you're on speed to begin with. An open descent is when you reach up here and pull this knob instead of push it, effectively the same as pushing flight level change in a Boeing product. In an open descent, you pull the knob. First, you set the altitude that you want to descend to here. You pull the knob into open descent. The engines will roll back to flight idle. The aircraft will pitch down to match whatever airspeed you have set in the speed control here. And the aircraft will descend unrestricted to whatever altitude you have set in the mode control panel. In this case, with the autopilot off, all this is doing is giving you the flight director indication to fly this profile. That's these two green bars right here. Flight director. Paragraph E. Karachi approach inquired, confirmed track mile comfortable for descend, and later advised to take an orbit so that the aircraft can be adjusted on the required descent profile. We'll go back and look at the instrument approach plate. No orbit was executed, and the effort to intercept the glide slope and localizer of ILS was continued. The flight data recorder indicated action of lowering of the landing gear at 7,221 feet at around 10.5 nautical miles from runway 25 left. So the crew did initially lowered the landing gear. Now, at the time that they lowered the landing gear, the airspeed was about 250 knots. Remember, the Airbus has a 260 knot safety limit that prevents you from lowering the landing gear above 260 knots. It's not clear in this report if this was the case. So all we know at this point was the gear handle was selected to the down position. Back on the ILS for 25 left instrument approach, this is the holding pattern that the air traffic controller is referencing. Even though his verbiage sounds a little unconventional to me, that's what he's trying to get the crew to do, to go into this holding pattern to slow down and descend. But the crew disregarded those instructions. Karachi approach advised repeatedly, twice, to discontinue the approach and once cautioned about excessive height. Landing approach was not discontinued. They just continued bombing on in. However, the flight data recorder shows action of raising the landing gear at 1,740 feet, followed by retraction of the speed brakes at a slightly less than 5 nautical miles from the runway 25 left. So massive confusion here. What's going on? They go to lower the gear. It's not clear as to whether they got the gear down or not, or whether the safety valve prevented the gear from actually lowering. And then they go to retract the gear. This indicates to me massive confusion in the cockpit. Are they talking to each other? Is one pilot thinking that we're going to go ahead and land, and another pilot thinking it's time to go around, we need to go around? Are they not? They're clearly not on the same sheet of music at all. And again, will all be made clear once we interpret the flight the cockpit voice recorder. We need to hear the conversation inside the cockpit. At this time, the aircraft has intercepted the localizer as well as the glide slope. Flaps 1 are selected at 243 knots indicated airspeed. They need to be getting down closer to approach speed at this time, well over 100 knots, way too fast. The landing gear and speed brakes were retracted. Overspeed and EGIPWIS warnings were then triggered. So they're attempting, let's talk about that. The warning you're hearing at this point, the gear's up, you're getting the too low gear warning, and you're overspeeding the flaps. Here's the flap limits for the Airbus A320. Flaps 1, 230 knots. What were they at? 245, 243 knots. And if you look at the profile, it looks like they were even faster than that. Here's the placard right on the instrument panel. Flaps 1, 230 knots. And also, this is indicated right on your vertical speed tape. Paragraph G, the figure here depicts a few of the parameters on the flight data recorder of the first approach profile of the aircraft in comparison with the required approach profile. Okay, so here is the actual desired 3-degree glide path, which you intercept. You get down here and level off about 3,000 feet at Abignale, intercept it from below, and then come on down. Here at Abignale, they're over 9,000 feet, 9,500 feet, where they should be at 3,000 feet. Look at the airspeed, 250 knots steady, and here's that spike where they got about 7,000 feet per minute vertical rate of descent, spiked the airspeed up to over 260 knots. At the same time, they're trying to lower the flaps to 1. So coming on in here at about just under 7,500 feet, the landing gear is selected down. So somebody on the crew is trying to lower the gear and get ready for landing. Just after that, ATC is telling them to take a turn in the holding pattern. Here again, ATC again tells the flight crew to abandon the approach and turn left to heading 180. But whoever's flying the aircraft, we still don't know if it's the captain or the FO. A final dive is made for the glide slope, and this is where they get 260 knots, 7,000 feet per minute. And just as they hit the glide slope, somebody selects the gear up. So, again, are they going to go around or are they going to land? There's massive confusion in the cockpit. The flap slat lever position is made all the way out to the flap slat 3 position. Whether the flaps themselves made it out to the flaps 3 position will remain to be seen on the flight data recorder. Well, I'm not sure if that's true. If the flight data recorder only records the position of the handle or the actual position of the flaps, because the flaps have a blow-up capability. If you lower the flaps at too high of an airspeed, not only are you going to get an overspeed warning, but the flaps have built-in blow-up capabilities which prevent damaging the flaps by trying to lower them at too high of an airspeed. Regardless, it looks like the crew at some point got flaps 3 on the lever position while they continued this approach at way too high of an airspeed without the landing gear extended into runway 25 left. Paragraph H. Now a whole nother series of confusion erupts with the air traffic control of Flight A8303. Since the approach to land was continued, Karachi approach, remember you got the en route controller, the approach controller, and then the tower controller, or as they call aerodrome control here in this report. Since the approach to land was continued, Karachi approach, instead of changing the aircraft over to aerodrome control, the control tower, they instead sought telephonic landing clearance from aerodrome control. The aerodrome control conveyed a landing clearance of the aircraft without observing the abnormality that the landing gear was not extended to Karachi approach. Subsequently, Karachi approach cleared the aircraft to land. Though ATC can maybe help you if in the event that you have an improper landing configuration for your aircraft, it's still ultimately up to the captain to make all this happen. Paragraph I. At 500 feet, the flight data recorder indicates that the landing gear was retracted, slat flap configuration 3, that's per the handle, airspeed, 220 knots indicated airspeed. Let's go to flaps 3. The flaps 3 speed limit is 185 knots. So they're well overspeeding the flaps. So they're getting plenty of warnings for flaps and gear. And a descent rate of 2,000 feet per minute. So at 500 feet, they should be on approach speed about 120 knots. Instead, they're doing 220 knots, so a full 100 knots too fast. And a descent rate of 2,000 feet per minute at 500 feet, your maximum allowed rate of descent should be more on the order of 1,000 feet per minute. So fully twice as fast of a descent rate, all caused by the high airspeed. And of course, the completely wrong configuration for the aircraft. As discussed in prior updates, stabilized approach requirements requires that you have your aircraft stabilized on approach speed and proper configuration by 1,000 feet with your airspeed under control no later than 500 feet above the ground. According to the flight data recorder and cockpit voice recorders, several warnings and alerts such as overspeed, landing gear not down, and ground proximity alerts were disregarded. The landing was undertaken with the landing gear retracted. The aircraft touched down the runway surface on its engines. Now this gets really ugly. Flight crew applied reverse engine power and initiated a braking action. So this indicates to me that the crew was completely caught surprised that the gear was retracted. Whoever was flying the airplane fully expected the landing gear to be down. Both engines scrubbed the runway at various locations. We talked about that in a previous update, causing damage to both of them. Figures hereunder show selected screenshots of security CCTV camera footage of the aircraft engines touching down the runway and showing sparks due to scrubbing along the marks on the runway. So there's the actual evidence that folks were looking for of this happening. And we talked about these scrape marks before. This will damage the engines. Paragraph J, aerodrome control, that's the control tower, observed the scrubbing of the engines with the runway and did not convey this abnormality to the aircraft. Normally, you'd be on the radio yelling at them. Well, normally, you'd be on the radio communicating with them all the way down. But because of some kind of an ATC mess-up, the tower never got into direct contact with this flight. They were using the telephone to Karachi approach. It was conveyed to the Karachi approach on telephone. Subsequently, Karachi approach also did not relay this abnormality to the aircraft. Things were just snowballing out of control too fast at this point. Okay, paragraph K. Here's where they seal their fate. This is where I think they were caught by surprise that the landing gear was down. The landing was discontinued and a go-around was executed. You cannot begin to do a go-around once you've applied reverse thrust and or the ground spoilers have come up on the wings. Now, there's no indication as to the status of the ground spoilers in this report, but it's much too late to do a go-around at this point, especially after you've already hit the ground on the engines. Again, this indicates to me that they were totally surprised of all of this, and they're just simply reacting. Yes, certainly it would have been safer and better for them to stay on the airport at this time, stay on the ground. The landing was discontinued and a go-around was executed. The flight data recording indicates a brief action of selecting a landing gear lever to the down position, which was immediately followed by its movement to the up position. So whoever's not flying the aircraft is just completely confused and just doesn't know what to do with the landing gear at this point. Intention to undertake another ILS approach for landing on runway 25 left was conveyed. However, shortly after the go-around, both engines failed one at a time. The ram air turbine, the RAT, was deployed to power the essential systems. Again, this would be an automatic deployment of the RAT. I'm sure these guys didn't have the wherewithal at this point to reach up there and deploy the RAT. The RAT will automatically deploy when both engines quit based on the loss of main AC power from the left and right generators. Flight data recording stopped during this time frame as per design limitation. Now, this is something unusual about the Airbus that I do not know about. Has this Some of you Airbus engineers out there, has there been a change to the design to not allow this to happen? Normally, I would expect the flight data recorder to continue recording in an emergency electrical configuration and or with some battery power. In this design of this serial number of aircraft, it appears that once normal electric power was lost, the flight data recorder was lost. So the flight data recorder, after the engines failed, that data is lost. That's why when you go back into the report, engineers or accident investigators had to use other sources of data to determine airspeeds and configuration other than using the flight data recorder for the final moments of the flight after the engines quit. The aircraft was unable to maintain required height. The aircraft declared an emergency situation and both engines were lost and transmitted the Mayday call. Evidence from the wreckage indicates reasons for right engine failure from hitting the runway so hard. However, left engine requires further examination, and landing gear in extended position did not demonstrate any malfunction of the landing gear system. So the landing gear, it appears as though the landing gear system was working normally. It appears that the right engine failed because of the damage it sustained hitting the runway. The left engine, what caused that engine to fail at this time, is still unknown, which brings up the question, in handling an engine failure, there is the possibility that the crew could have shut down unintentionally the one remaining good engine. It's also entirely possible that the left engine failed due to the same thing the right engine failed from, damage caused by hitting the runway. Remember, in previous updates, we talked about the accessory drive gearbox being mounted on the bottom of that engine, and if you smash it onto the runway, you're going to smash that accessory drive gearbox, which contains all the vital functions of things like fuel control unit, hydraulic power, electric power, and everything else to keep this engine running. Paragraph L. The aircraft crashed about 1,340 meters short of runway 25 left. It was a slow speed impact with a high angle of attack with aircraft configuration indicating landing gear extended, slats at step or position 1, and flaps retracted. The said configuration was ascertained and documented from the wreckage at the crash site because the FDR quit recording. Now, this Airbuses, under normal law, with all the electrical system working, you cannot stall an Airbus. However, under alternate law and or direct law, which investigators are going to find out that this aircraft was in because of the emergency power configuration, yes, you can very easily stall an Airbus aircraft. And at flaps 1 and 150 knots, I bet investigators are going to find out that that crew ended up stalling that aircraft into those buildings. But at that point, what are you going to do? The aircraft was reportedly serviceable for the said flight, and necessary scrutiny of aircraft maintenance records and documentation is underway. The captain and first officer were adequately qualified and experienced to undertake the said flight, necessary scrutiny of the aircrew records. Further documents are underway. So, the way forward, where do investigators go from here? They're going to continue to extract the data from the flight data recorders and the cockpit voice recorder. We got to hear the whole conversation on the cockpit voice recorder all the way back to the beginning of this flight, if that's possible. That is going to tell the story. They're also looking at the fact that this aircraft was on the grounded for 46 days for the COVID-19 from 22 March to 6 May, but this aircraft did fly after 6 May before this accident. I don't think there's going to be much to learn from there. And most importantly, they're going to do the critical analysis of the performance of pilots by Pakistan International Airlines for stabilized approaches, which we've been beaten on continuously here, the use of flight data monitoring analysis tools, crew resource management, supervision of simulator sessions, and related regulatory oversight by the Directorate of Flight Standards. Also, they need to carefully assess the safety management system at Pakistan International Airlines, the state safety program, and the CAA for safety oversight of the entire operation, and evaluation of the safety and quality management system over at Pakistan International Airlines, because the folks at Pakistan, in Pakistan, deserve better. This is just a tragic, long error chain of human-driven events. So thanks so much for your support of this channel. This report is brought to you by the folks that sponsor this channel over on Patreon. Thank you so much for your support. See you here.